All right, so this week we're going to start off by finishing up section 2.2. And really, we're just going to start with a problem. There's really nothing I need to explain. We'll just take a look at an example. Okay. In this example, it's going to be about a company that produces something. I think it's T-shirts. And the company has two types of costs. They have fixed costs and they have variable costs. So you could think of a fixed cost as maybe if you rent a building, how much you pay per month to rent that building. Okay. How many T-shirts you make in that building, it doesn't matter. You pay the fee to rent the building, you can do whatever you want with the building. But then the variable costs would depend on how much of the product you make. Right? So if you're making T-shirts, a variable cost might be how much material you buy, because the more T-shirts you make, the more material you buy. So that cost could change. So this particular company has a fixed cost of $200,000. Okay, again, maybe that's to rent the building, maybe that's the salary of the people, assuming the people don't get paid based on how many shirts they make, they make the same amount of money. And there's a variable cost of $1.50 per shirt. Bless you. Okay, they're going to sell each shirt for $4. Now, some terms that you're going to see here, we're going to see really three terms: cost, revenue, and profit. Cost is the money that they have to spend. Okay? To rent the building, to pay employees, to produce the shirts, it's money they spend. Revenue is going to be money that they take in. Okay? It's just money they take in. The profit is the difference between the two. Okay? So if you take how much your costs were, or take your revenue, subtract out your expenses, then you're left with how much money you made, or your profit. Okay, so the first thing they want us to do is come up with an equation that represents cost, and then another equation for revenue. Okay, and then we'll graph them. All right, so anyone think they could give me an equation that would represent the costs? And remember to take into account the fixed cost and then the cost that changes depending on how many shirts you make. Yep?
Well, I had 1.5x minus 200,000 plus 4x.
So just the cost. Don't worry about the revenue yet. But I see where you're going, and we'll talk about that. But how about just for cost?
Just for cost?
Yep.
1.5x minus 200,000.
1.5x.
Oh, no, plus 200,000.
Plus 200,000, right? Because you have to take the variable and the fixed cost and add them together. Okay, so there's your fixed cost. And how about your revenue? What's the money that the company takes in? And again, don't worry about profit, just the money that they sell the shirts for. Yep?
4x.
4x. Okay. So any questions on how I got the cost or the revenue equation? All right. So you used X, but I should ask you, what does X stand for?
How many shirts they sell?
Exactly. How many shirts they sell or produce. Yep. All right. Mylery, since X is how many shirts they sell, what kind of numbers would make sense for shirts that you sell? Positive numbers? Could you sell 0 shirts? Yeah, you could sell 0. Could you sell fractions of a shirt? No. So really, we're just looking at numbers 0 and up. Fractions and decimals don't make sense. All right, so for my window, we already know that this graph has a y-intercept at 200,000, so we're going to have to go at least that high. I'm going to go 350,000. Whoops, that's max. So let's put that for max. Y is the cost or the revenue, depends on which equation you're looking at. Either way, you're never going to have negative cost. That doesn't make sense. And you're not going to have negative revenue. You could have negative profit, but that's different. Okay, so there's no negative cost. And Y max, how much our costs could be, we don't know. Let's set it up to around 300,000. Let's hit graph and see what it looks like. Okay, so looks like I have two lines, and that's just because my window, I think my window is a little too big. Let's try setting that to 35,000 instead of 350, and see if we start to see. Okay, so we're starting to kind of see a little bit, but I still think X max is too big. Let's try 3,500. All right, so we're kind of starting to see it, but oh, I have to type in the equation. That's why. So 1.5x plus 200,000 and 4x. I'll try the window I have and see what it looks like. Okay, so that's my cost. That's my revenue. Okay, now I can start to see what's happening. What should I set higher if I want to see where these cross? Yeah, the x. And it probably was fine where I had it. I just hadn't typed in the equation yet. So I'm going to try 35,000. And we'll see if we can see them crossing. Not quite. So I'm going to put x right back where we had it. 350,000. I was wondering why that wasn't working. Okay, I'm pretty good, except I just need to adjust what now?
The Y.
Yeah, let's make the Y max a little bit higher, and then we'll see where they cross. So let's try, I'm just going to try 400,000. Okay, so there's my cost. There's my revenue. Good enough. Okay, so there's my graph. What's happening right there? It's where your cost and your revenue are crossing.
That's where you start making profit.
That's where you start making money. Does anybody know what you call that? Yep.
Break even or something?
Yeah, that's your break-even point. So it's the point at which your cost and your revenue are the same. After that point, you're making money. Before that point, you're still losing money. Okay, so we already answered this question. For a graph, where is cost and revenue? It's where they cross. So let's figure out the number of shirts that we have to sell in this example to actually break even. And then once we do that, that'll be the last one in this section. And we'll be all done. Okay, first way we'll do it is algebraically. So to break even, let's go back up. It's where cost equals revenue. Okay, so if you want to think about it as an equation, it's where cost equals revenue. Okay, so now just go back to the other page and find your equation for cost. Plug that in. Find your equation for revenue. Plug that in, and then solve it. All right, so Julia, what's my equation for cost?
Am I still reading
Yeah, same thing we did. We're using the same problem.
1.5x plus 200,000?
Good, 1.5x plus 200,000. Brandon, what is my equation for revenue?
I don't know, I was not paying attention, sorry.
You want to help him out? What's the equation for revenue? It's R of x. Yeah, go ahead.
4x.
Yeah, so as AJ just said, 4x. And now we just solve it. 200,000 equals, if I subtract, what's 4 minus 1.5? 2.5.
8,000.
And then divide each side by 2.5 and you get 80,000. Yep. And what is that? 80,000 shirts. Okay, so there's our break-even point. Okay, graphically. Graphically, there's really not much we haven't done here. In fact, we're already set up. We just want to do an intersect now. So second calc intersect. Pick a point on the blue, the red. Does the guess matter? No, because there's only one intersection, so it'll find it. I'm not sure what that little thing is over there. But, there's my intersection. Did it really?
Yeah.
Yeah, that's weird. It definitely shouldn't be there. But it happened on all of them?
It happened to me. I think that the little like, button thing,
Yeah.
the intersect thing, I think it was too far up. So I think it just did that. I
It
don't know.
just did that. Yeah, that's weird. But either way, you get the right answer, 80,000 shirts. What's the 320,000? I mean, I know it's the Y value, but what does that mean? Yeah,
It's the money.
money, your cost, your revenue, or both?
Both.
Both, yeah. If you make 80,000 shirts, it's going to cost you 320,000. And if you make 80,000 shirts, you're going to take in 320,000. You're going to break even. After that point, when you sell 80,000 in one shirts, now you're making profit. Okay, so that's it for 2.2. Any questions on that? Okay. All right, so let's take a look at 2.3. So 2.3, probably a little bit of a review from Algebra 1. More of a refresher. But we'll talk about solving linear and quadratic equations. Okay, so first of all, what is an equation? Basically, with an equation, you've got something on the left, something on the right, equal sign between them. Okay, so in order to have an equation, you've got to have an equal sign. If you have an equation that uses x as a variable, you could say you have an equation in x. I'll go back to that in 1 second. That is an equation in x. All that it means is it's an equation with the letter x in it. So if I ask you on the test or in the homework, write an equation in Q. Just means use Q as the variable. That's all. Okay, so to solve an equation, it means to find all values for the variable that make it true. If you're solving something like a linear equation, how many answers would you get to a problem like that?
One.
Just one. Okay, when you solve linear equations, you're only going to get one answer. When you make the exponent a little higher, like that, now you get two answers. Right? There's two numbers you can square and get 9. 3. And what else? -3. Okay, so some equations might have two answers, some might only have one. But either way, to solve it means to find all values that make the equation true. If you were to solve that equation I just wrote down, does anybody see what would happen?
The x's and
Okay, what would you get on the right-hand side if you did that out so we can see what you just said?
2x plus 3.
Yeah, you get the same thing on the left and on the right. So if you subtract 2x from each side, you just get 3 equals 3. Does anyone remember what that means when the x's cancel out? What could you pick for x that would make that equation true? 2x plus 3 equals 2x plus 3. All real numbers. You could pick anything. Because if you've got the same thing on the left and the right, you could pick any number for x. Positives, negatives, fractions, or decimals. That's an identity. It's an equation that's true for all values of the variable. And of course, you're assuming that you're only plugging in values you're allowed to. As always, never plug in a number that would cause you to divide by 0. Don't plug in numbers that would give you square roots of negatives. Neither which happens in the example I gave you. Okay, so that's an identity. There's another example of an identity. Versus a conditional equation is an equation that could be true if you pick the right value for x. Maybe there's one value that makes it work, maybe there's two values, maybe there's three values, but there's not infinite values, not like an identity. So in this particular problem, 5 would be what makes it true. Okay, any questions on the difference between an identity and a conditional equation? All right, so if you want to check if a number is a solution, you plug it in and see if you get a true statement. So in this problem, I'm not going to ask you to solve it because it's a cubic. That would be a little hard to solve by hand. But I'm going to give you a number and ask you to check if it's a solution. And since I use the word verify, that probably means it already is a solution. I just want you to double check that it is. All right, so Matt, how would I check that -2 is a solution? Doing okay? How would you check that -2 is a solution to that? What would you do? You don't have to put the 6 on the other side. You can leave it just like that. Replace x with -2. Yep. So let's plug in -2. I like to use parentheses when I do it, just try to keep things clear. I'm going to put a question mark there because we don't know if it equals 0. That's what we're hoping. All right, so Colin, what's What's negative 2 cubed? How much?
8. Negative, sorry.
Negative 8, yep. Minus a minus, that's going to become a plus 2. Plus 6. Then how about Casey? Negative 8 plus 2?
It's negative 6.
Negative 6. And now I think we can see negative 6 plus 6 is 0. We've got the same number on the left and the right. We verified that negative 2 is a solution. Okay. Any question on how to check your answer when you solve an equation? Okay, pretty straightforward. Okay, so this is what a linear equation looks like if you set it equal to 0. And what this says on the left-hand side is that A and B can be, does anyone remember what that R symbol means? Yeah. A and B can be any real number that you want, except A can't be 0. Because if you fill in a 0 right here, 0 times x is gone. Now you don't have a variable anymore. That's not a linear equation. That would be what we call a constant equation. Okay, so A and B can be any real number except A can't be 0. Every single linear equation, even this one, you can make it look like that. If you combine all your x's together, you move them all to one side, and combine all your constants and put them on one side. Okay, but generally, at least with linear equations, we don't get them equal to 0. We get the variable by itself. With a quadratic, you do that. You get 0 on one side, so then you can factor it, or use quadratic formula. But I don't really think we're going to rearrange it with 0 for linear. All right, so Hannah, what would my first step be on the left?
Distribute.
Yeah, what are you going to distribute?
The 2.
The 2? Anything else?
And the 3.
And the 3. Okay, so we'll distribute all that out. Andrew, what do I get when I distribute out the 2?
4x minus 6.
Good, 4x minus 6. And Colleen, when I distribute out the 3?
3x plus 3.
3x plus 3. Okay, now before I start moving things from side to side, I should combine everything together that I can on one side. Gabby, what do I get when I combine my x terms? 7x. And now I have my constants. Mike, what do I get when I do a negative 6 plus 3? Oh, sorry. Yeah, go ahead, Mike. Yeah, negative 3. Now we're ready to start moving stuff from side to side. Mina, what would I do next?
Subtract 5x and equals 7.
Yep.
And then add 3.
And add 3. So I'm going to do it all at the same time. Subtract 5x, that's gone. Add 3, that's gone. So you're left with 2x equals 5. Kelvin, my last step. Divided by 2. There's your answer. X equals 5/2. Okay, so at this point, I'm going to assume you could solve any linear type equation. Distributive property, combine like terms, add, subtract, all that stuff. Okay, if you do need more help with linear equations, let me know, but that's really more Algebra 1 kind of stuff. Okay, any questions on it? Okay. Absolute value equation. So absolute value equation is going to look something like, I'll just make one up. Usually it's all the same color, but it could look something like that. So the goal with an absolute value equation is first you have to isolate the absolute value expression, meaning on one side of the equation, all there is an absolute value and nothing else. That is no longer isolated because now you've got this plus 2 on the outside. So my first step on this kind of problem would be to minus the 2 from both sides. Another way you could have the absolute value not by itself, if you had 12 times the absolute value, first thing I would do is divide each side by 12, okay, to get that 12 on the other side. So any questions on what I mean by isolate the absolute value expression? Okay, that's your first step. The second step is to split it into two problems. Okay, the first problem is exactly the same as the original. All you do is take away the bars. Okay, and then you go ahead and you solve it. Okay, so it's exactly the same as the original, just take away the absolute value bars. Okay, the second equation that you get, you start out the same way. You take the original, you get rid of the bars, but you also change the sign of the number. That's what that word means, negate. Change the sign of the number on the other side. Okay, so in this problem, my other equation would be x plus 3 equals negative 6. Okay, so negate doesn't mean make it negative. Negate just means change the sign. If it's already negative, make it positive. If it's positive like it was in my example, then you make it negative. So since we're splitting it into two problems, most of the time an absolute value equation is going to have two answers. Okay, so let's look at this one. Absolute value of 2x plus 3 equals 5. Okay, first thing I want to ask myself, is the absolute value by itself?
Yeah.
Yes, absolute value is already by itself. Can somebody give me one of the two equations that I'm going to split that into? Casey?
2x plus 3 equals 5.
Yep. So you're going to solve that one. 2x plus 3 equals 5. And I'm going to write down my other equation. What would be my other one? Yep.
Wouldn't it be 2x minus 3 equals negative 5? Or that'd be 2x plus 3 equals negative 5.
Yes. 2x plus 3 equals negative 5. And now solve each equation. 2x equals 2. X equals 1. And, okay, we get another answer. Subtract 3 from both sides, you get 2x equals negative 8. Divided by 2. X equals
Negative 4.
negative 4. Good. Hey, any question on that one? So I said an absolute value equation could have two answers, and this one does. And just to show you what that would look like when you graph it, it's going to cross the x-axis in two spots. Does anybody know what an absolute value looks like when you graph it? Yeah?
It's a V.
Yeah, it's a V shape. So 2x plus 3. And what I'm going to do is, to graph it, I'm just going to get it equal to 0, okay, like I was solving a quadratic. So 2x plus 3 minus 5 equals 0. I hit graph, and watch the two spots where it crosses the x-axis. 1, -4. Those are our two answers. So let's say I did something like this to it. Make it a +5. Where does that graph cross the x-axis now? It doesn't. So does anybody know what kind of, well, there would be no solution to that. You can't solve that one. But does anybody know how that would look here? What would an equation look like that does not have a solution? Well, think about absolute value. What kind of number is absolute value? It always comes out what? Positive. So if you did something like that problem right there is exactly that graph right there. Because you're trying to get absolute value to equal a negative, that's impossible, and it'll never cross the x-axis. Okay, so if you have a situation like this, don't split it into two problems and solve it. You'll get two answers, but they won't work. Okay, so if absolute value equals a negative, no solution. What if you had something like this? Is that one a no solution? Why not? It's equal to a negative.
Isn't your first step to move it along?
Right, my first step is to get this by itself. Until that's by itself, I really don't know what I'm dealing with. And I would add 8 to each side. Now it's not equal to a negative. Now it's equal to a positive. Okay? So always make sure you get that absolute value by itself first. Okay, mixture problems. So the type of word problem we're going to look at in this section is a mixture problem. So the idea with a mixture problem is you're going to take two separate liquids and mix them together. So there's two things you have to write an equation for. One is when you mix them together, how much stuff do you have? Are you mixing things together to create 50 gallons of something, 100 gallons, 200 gallons? Okay. That's your first equation. And amount 1 and amount 2 don't have to be the same. Maybe you're going to mix 2 gallons of one and 13 gallons of another. Okay? But you're going to mix two things together to get a certain amount. And then your second equation is for what we call the concentration. All right, so maybe you have a solution that's 10% strong. Maybe it's like rubbing alcohol or something. You've got a 10% solution, and you've got a 15% solution. And someone tells you, all right, I want you to create 100 gallons of a 12% solution. So you're going to have to mix some of the 10 and some of the 15 in the right amounts to create a 12% solution that's 100 gallons. So the percent, that's your concentration. We just have to make sure we always write as a decimal. So 10% would be like 0.1, 15%, 0.15. Those are the two equations you need to set up. Okay, everybody have the two equations? So we have two solutions, a 10% and a 25%. Okay, I want to mix them together so that when we're done, we create 15 liters. And we want the solution to be a 12% solution. How much of each one do we need? So let's call, since this is already labeled A and B, we'll say of the 10% solution, we're going to use A liters. And for the 25% solution, B liters. You can use X and Y, but it just makes sense since they're already labeled A and B. Okay. Anyone think they can give me my equation for just the amounts? What plus what is going to equal what? Don't worry about the percentages yet. Yeah, Josh?
A plus B equals 15.
Yeah. A plus B is going to equal 15. Now we got to set up the second one, concentration times amount. What's the concentration of solution A?
10%.
10%, and as a decimal? 0.1. So concentration times how much? Plus concentration times how much? What's the concentration of solution B? And how much of that one are we using?
B.
B. So 0.25 B equals
15.
the final concentration times the final amount. What's my concentration of the final liquid? 0.12. And what's the final amount? 15. All right, and since that's just a number, 0.12 times 15, we can simplify that and just say 1.8. Okay, when I rewrite it again. Now, I need to solve that top equation for either A or B. And it doesn't matter which one we solve it for. So Josie, you want to solve the top equation for A or B?
We can do A.
All right, let's do A. So what would A equal? I'm just going to put it off to the side.
Is that a 1.5?
15.
Oh, 15, okay. It would be 15 minus B.
Yes. So now we're going to take that and plug it in right there. Okay, so we're going over substitution. That's what we're doing right now. So we've got 0.1. And then instead of A, we're going to write 15 minus B. Any question on that? And now just copy everything else. Plus 0.25B equals 1.8. And now we had a problem like that earlier. Distribute that out. What's 0.1 times 15? 1.5. So distribute out the 0.1. Okay, like terms, negative 0.1 plus 0.25.
Why are you subtracting 0.1b?
Because of that right there.
Oh, yeah.
That's that. What's negative 0.1 plus 0.25? 0.15. Plus 0.15b. Subtract 1.5 to the other side. What's 1.8 minus 1.5? Point. Yep, 0.3. And my last step, divide by 0.15. Okay, what's 0.3 divided by 0.15? So we need 2 liters of solution B. And how many liters altogether when we mix this up? 15. And we've already used 2.
13.
So 13 of the other one. And that's pretty much how every mixture problem goes. Any questions on the mixture problem? Okay, so for linear equations, that's pretty much all we're going to do. We talked about substitution. Now we'll get into finishing up with quadratics. Okay, quadratics will be the last thing we do today. Okay, so starting out just like I did with linear. Okay, quadratics are of that form if you get them equal to 0. A, B, and C can be any real number that you want, except A can't be 0. What would happen if you made A 0?
One word.
What would it turn into? It would turn into linear. Right? If you make A 0, now you have bx plus c. That's like mx plus b. That's a line. So A cannot be 0 in a quadratic. Okay, so one way to solve a quadratic is to factor. Okay, so the first one I give you will be a problem that's factorable. Okay, so 2x squared plus 5x minus 3 equals 0. And when I want to factor a quadratic, besides getting it equal to 0, that's the first step. Okay, this one already is. What's the first thing you write down when you want to do factoring? Exactly, you got to put down your symbols, right? Put down your parentheses. And then we have to decide what's going to be the first term in each parenthesis. Okay. Anyone think they could tell me what would go in the first and in the second parenthesis? So when you multiply them together, you get 2x squared.
X squared, or x squared and then x. I have no idea. 2x and then x.
2x and x, yeah. What's nice about 2 is there's only one way to get it. If this was like a 12, then you could try like 4x and 3x, or 6x and 2x, or 12x and 1x. But since it's 2, it's a prime number. There's only one way to get it. How about my signs? Yep. Whenever this term is negative, you need one of each. My suggestion would be try it like that first. And now 2 numbers that multiply to give me 3.
3 and 1.
3 and 1. I'm going to put them in the other order, though. 1 and 3. Okay, let's check it. We have 2x squared. 2x times 3 is 6x. Negative 1 times x, that's minus x. And we're good. Okay, so now we factored it. And how about, Hannah, what do we do with each factor?
Set equal to 0.
Yep. Set up 2 equations and solve each one. So you get x equals a half and x equals negative 3. Okay, so any questions on factoring? In Algebra 1, I mean, this is something you spend like 3 or 4 days on. We're not spending 3 or 4 days on it. That's pretty much it. Okay, so the key, make sure you always get it equal to 0 before you start factoring. Okay, if you can't factor it, another formula you learned in Algebra 1 is the quadratic formula. Anybody remember what the quadratic formula is? Yeah?
It was like -4 plus or minus b square root of 4ac minus 2a.
You got all the right stuff going.
Something like that.
You got it all going, just a little bit rearranging. So we got -b plus or minus the square root of b squared minus 4ac all over 2a.
Cool.
You had the right stuff. Okay. Remember that this thing under the root that I circled in blue, that part of the formula has a special name. That's the discriminant. And the discriminant is used to tell you how many solutions your problem will have. So if all you want to know is, here's a quadratic, how many solutions does it have? Do b squared minus 4ac. And I think we talked about that earlier. If it comes out negative, there's no solution. If it comes out 0, 1 solution. If it comes out positive, 2 solutions. But if you want to actually know what the solutions are, you have to go through the whole problem. Okay. Also, when you use this formula, just like when you factor, make sure you get it equal to 0. So it should be written just like this. So a is just the number in front of x squared, b is in front of x, c is the constant. All right, so let's look at that one. So example 6, it says 2x squared plus 2x equals 1. AJ, is that equal to what it should be? No. What should it be equal to?
0.
And how would you make it equal to 0? Subtract 1. All right, so now we're ready to fill those in. So A in this case would be 2. B, it's also 2, and C, -1. So now just plug everything in. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. What's going to happen when you subtract a negative? Yeah, you're going to multiply the 4 times 2 times -1, but then that's going to be a negative, and you're going to subtract it. So what happens when you subtract a negative? It's just going to become positive. So right away, I'm just going to make it positive. Okay, 4 times 2 gives me
8,
plus 4,
12.
12. And now if you don't simplify, that would be your answer. But the square root of 12 simplifies.
3.
To what?
Wouldn't it be -2 plus or minus square root of 3?
Square root of 3 would be part of it. What's the square root of 12 simplify to, Ian?
2 square roots of 3.
2 square roots of 3.
Right.
And now what can you cancel from everywhere?
2.
A 2. Becomes a 1, 1, 2. Okay, so your final answer would be -1 plus or minus root 3 over 2. Okay, so generally on the test, we're going to look for it reduced. Okay. And again, quadratic formula is something you probably spend a couple days with in Algebra 1, and, but that's all we're going to do with it. Is there any questions on that one? Okay, so it's just kind of a quick review. All right, so this will be, yeah, this one. All right, so last problem is going to involve a quadratic equation somehow. And here's a picture to kind of explain what we're doing. you've got a rectangular piece of cardboard, and you're going to cut squares out of each corner that are 5 by 5. And then along the dotted lines, you're going to fold up the sides to make like a tray. Okay, W and L represent the width and the length of the original piece of cardboard. And I already said to that part to you, the cardboard is going to be folded along the dotted lines to make a box. And the goal is going to be to find the width and the length of the original piece of cardboard. So after they describe the problem, they tell us two important things. The length is twice the width. And the volume, when you create that box, is 2,040 cubic inches. Find the dimensions of your original piece that you folded. Okay, let's start with the length is twice the width. Anyone tell me how I could write that as an equation? The length is twice the width. And we'll use L and W for your letters. Yeah.
Length equals 2W.
Yeah. Okay, so keep that in mind. Length equals 2W. Volume. So we're doing something with volume. And the shape we have is a rectangular prism. What's the formula for a volume of a rectangular prism? Nina?
Length times width times height.
Yeah, the volume is length times width times height. All right, so volume equals length, width, height. Let's fill in what we know. Volume, 2,040 cubic inches. Okay, length. For now, I'll come back to L equals 2W, but for now, let's just look at our length. That's your length. Okay. How would we... Actually, I'm sorry. That is your length. So, how would we write that length down? That line I just drew in red. Think about it as like taking away something on each side. Yeah?
It would be L equals
It's going to be minus something. It's going to be L minus something to just get that piece in red. Because remember, once you fold up the box, your length, it gets a little shorter than the original piece because the sides, you have to have sides in the box, so you're folding them up.
minus 10.
Yeah, it's going to be L minus 10. That's your length. And how about your width? Just this part in red. That's the width of your box.
Would be minus 10 too.
Yeah, that would be W minus 10. And what's the height of my box? How tall are the walls going to be? Yeah, when you fold them up, that's going to become your height. That's going to be 5. Now, the problem with that is you've got two variables, L and W, but what do we know L equals? 2W. So I can change that to 2W. So 2,040 is 2W minus 10, W minus 10, and 5. Now, one thing you can do that kind of a little trick is, what could you factor out of a 2w and a 10?
2.
You could factor out a 2, and it would leave you with that. And the reason I did that is because it's going to make all my numbers a lot smaller. Does anyone see what you could divide each side by? And it would cancel the 2 and the 5 at the same time. How much? Yeah, if you divide each side by 10, well, 2 times 5 is 10, so you canceled both of them. You don't have to do that, but it does make the numbers a lot smaller. And then here, you're left with 204. So we get 204 equals w minus 5, w minus 10. When we solve a quadratic, what number do we usually get it equal to? 0. 0? W minus 5, w minus 10. And how would you get the 204 on the other side? Subtract 204. And what I'll do is I'll FOIL this out. W squared minus 10 minus 5 is how much? Negative 15w. What's negative 5 times negative 10? 50 minus 204. Okay, it gives you negative 154. And now, how could you solve it from there? Yep, factor. Or what else could you do if factoring didn't work? Yeah, you could do the quadratic formula. I think that does factor, just to save us a little time on the factoring. It factors as w minus 22 and w plus 7. Again, I might not see that, so I might have to just use quadratic formula. So that means you get 2 answers for the width. What's one answer? 22. And the other answer? Which one doesn't make sense? Negative 7. So if your width is 22, and your length is double that, your length is 44. Okay, so that's a really quick review of solving quadratic equations and linear equations. Okay, homework tonight, page 89, 35 to 39, that's all one question. That's a break-even problem. So it's like one problem is write the cost, another one is write the revenue, another one is graph them, another one is calculate the intersect. Okay, so that's all one question. And then page 96, that's on solving linear and quadratics. Okay, so we'll take a look at that tomorrow. And again, don't forget that we have our third test on Friday, and I'll be after school for extra help on Thursday.